2, page 135 is grade A all the way, as I say. Check these out. You can see these are different straight away. Just look at them. Here's a baby one really. 2a squared plus 7a plus 3. First the grade A's. Why? Because there's a number there in front of the a squared, the x squared, the letter squared, and so there's more to think about. So you've gone from B to A in one step. Same thinking though. The way to make 2a squared is to go 2a times a. There's only one way to make 3, and that's 1 times 3. Be very careful. If you put the 1 and the 3 in the wrong place, it simply won't work. Check it. 2a squared, 6a, plus 1a, 7a, 1 times 3 is 3. If you flip them around the other way, it simply will not work. Let me prove it to you. You need to be able to test this for yourselves. Right, 2a squared, 2a times 1 is 2a, 3 times a is, missed the bracket there, 3 times a is 3a. That only gives us 5a, so that was never going to work. Alright, so that's correct, that is wrong. So test it out and be very, very careful before you start sticking factors in various corners of brackets willy-nilly. Don't do that. Now let's just jump to question 5 then, just to get harder quicker. 7e squared minus 2e minus 5. Now there's only one way of splitting off 7e squared, is to go 7e and e. Now how should we make 5? Again, prime number, only way to do it is 1 times 5. If I put a 5 there, I'm going to end up with 35 e's. I can't see making minus 2 e's out of that. I did that deliberately just to show you that if you do take the wrong move, then you can flip it around the other way and know that you're going to be correct. So 7 times 5 will make 35 e's. I'm not going to get 2 e's out of that. So 1's going to go there, 5's going to go there. Multiply out again. 7e squared minus 7e. In other words, that needs to be negative and that needs to be positive. Check it. 7e squared minus 7e plus 5e minus 7e plus 5e is minus 2e. So, and 5 times minus 1 is minus 5, so I'm happy with that one. Jumping over to question 12, I've got 2q squared plus 15q's plus 18. Okay, let's just bracketize it, factorize it, land it. So here we go. 2q and q. How do we make 18? Well, loads of ways of making 18. This is when the grade A starts to hurt. So I want to make 15 q's ultimately. So I'm going to go for 6 there and 3 there. Let's see if that works. Yes, I've got it in one. Look at that. 2q times 6 will give me 12 q's. Just keep a little tally there. 3 times q is 3q. That gives me my 15 q's, and it's all positive. All right. I'll leave that there as a little bracket so you can think about it. Alright, so there you go. That's how I did it. Again, this comes by experience. I don't get them right in one go. You don't have to get them right in one go because you're always at liberty to multiply out and see how they turn up, or rather how they turn out. Let me try 16. I've got 4w squared minus 21w's plus 5. Now, first one involving one of these. There's two ways of splitting up the 4w squared. I can go 4w and w. I can even go, and there's only ever going to be one correct answer, 2w and 2w. I'm going to try it to run with the 4w single w split first, but recognise that our computer's booting up, but recognise that this second one could be a valid answer, and if it's correct it will be the only correct answer. But let me try it anyway. Look, 1 times 5 makes 5. If I go 4 times 5, I've got 20 w's, and there's the extra w there, so I think that's going to be correct. Right, 4w times w, 4w squared. 4 times 5 will be 20, but I want it to be negative, so that's going to be minus 20w, and I want another minus w to make minus 21. That has to be negative as well. However, minus 1 times minus 5, what's that? Plus 5. So I'm completely convinced that's perfectly good, and I'm therefore going to put a lovely red line through that one. Alright, so again, I just showed you the possibility, I opened your eyes to the possibilities that this could have been possible, but it was impossible. But you don't know until you try. I want to try one of these wonderful difference of two squares again. I've got 9y squared minus 25. I don't know why this is grade A, but we'll do it anyway. Shut it up. That's basically 3 squared times y squared minus 5 squared, isn't it? You don't have to show these steps if you don't want to, but I'm just showing you that every little part of this is square. Hence, I can do thus. So 3y minus 5 and 3y plus 5. They're multiplied together, these two brackets, and that will give you that for sure. What else? Turn over the page, I think. What else is difficult? Now, I'm going to write this down, you read it. When you're asked to factorise completely, it means take it as far as it can go all the way. The implication is there's more than 2 factors involved. You could be talking about 2 brackets plus something else as well. Now look at this one. 2x squared plus 10x plus 8. And I'm told to factorise completely. An examiner will do that. They'll say factorise completely. Hint, there's 3 factors. Now look, 2, 10, 8. Straight away, the common factor of all those is 2. So take a 2 out of everything. What's left? X squared plus 5x plus 4. And we've got a very, very simple grade B quadratic. So we're going to have 2, bracket, 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 closed. And then we ignore the 2 now, because now we're going to focus our mind on this very simple quadratic that we're left with. So x times x is x squared, 4 times 1 makes 4, and 1 plus 4 makes 5. That's it. 3 factors. 1, 2, 3, 3 marks. Thank you. I'm happy. Let me try number 20. It's in this sort of category of factorising completely. Right then, here we go. 3, 9, 6, common factor 3. Oh, by the way, these are all equal. Take 3 out. I've got y squared minus 3, because 3 3s are 9. So 3y plus 2, because 2 3s make 6. So that's that bit sorted. I've got myself a mark. Again, a simple grade B quadratic requiring 2 brackets. Y times y is y squared. There's only one way to make 2. That's 2 times 1. They both have to be negative to make minus 3y altogether. And there it is. 3 factors, 3 marks. What else we got here? That looks terrible. I think I'll try number 22 just for fun. It's got here 3b squared minus 27. I've got to factorise it completely. Well, common factor of 3 and 27 is 3, so nick it out of both. B squared minus 9. Oh look, difference of 2 squares, because 9 is 3 squared. So I've got 3 bracket b squared minus 3 squared. Yeah, 2 square terms. And that will give me, sure you know this, b minus 3 with b plus 3. And that's lovely. I'm not sure I've got the brain to do that one just yet. I could think about it. Let's just try number 23. This is horrific. Do it up here. I've got 2x squared plus 7xy minus 15y squared. And the word says factorise. Well, alright then. I'm clearly going to have 2 brackets. There's no common factor from 15, 7 and 2, so it's not a factorise completely type thing. And I've got x's and y's, and that's really unkind. So there's only one way to make 2x squared, 2x and x. And clearly I need some y's down here somewhere. So y times y will make y squared. Now, how shall we make 15? Well, I don't know, 3 5s might do quite nicely. 3 5s will do 15. If I put a 5 there and a 3 there, we can test it out. Well, 3y times 5y will definitely give me 15y squared. It's got to be negative though, so let's just try it out. 2x squared, no problem. 2x times 5y will be 10xy. I want the 7xy to be positive, so I want this to be heavier than 3. So we'll try putting a minus there and see how it goes. Once more time, 2x times x, 2x squared, 2x times 5y, 10xy, so write it down so it saves me keeping it in my brain, minus 3y times x, it's going to be minus 3xy. And look, I've got my 7xy's that are positive, so I'm really happy about that bit. And finally, minus 3 times 5 is minus 15, y times y is y squared. So I know I've got it right, absolutely. And I'm going to stop there, because that's a sample of grade A quadratic equations, and I'm quite happy with the way that's worked out.